Uh, all right. Hey, folks. Great to meet you all. My name is Nikhil. I'm currently running a company called Fennel, which is a real-time featured space, machine learning infrastructure for recommendations in fraud and insurance and other problems like that. I worked with Mahesh at PyTorch, and before that, I was running a group of 100 machine learning engineers, and my group was responsible for recommendations and more generally AI ML of multiple product lines within the company. Part of feed, part of search, most of groups, dating, events, several more product lines. In my previous life, I worked at Quora, um, and I started a lot of their machine learning efforts as well. Based out of Bay Area, struggling to balance my life with a 1-year-old and a company that I'm running as well, and a huge fan of rap. So if any of you are rap fans, hit me up and we can chat about that. Um, all right. So as Mahesh mentioned, today we'll be talking about modern recommendation systems. I'll introduce the idea of machine learning going real time, and I'll take a few minutes talk a bit about what Funnel does, and through that hopefully understand more about the process, not just about the company. My promise is I will not use any jargon. I will not use any math. I will not use any technical terms. There have been multiple generations of recommendation system technologies. It's become a hodgepodge out there. I'll try to give a systematic, thought framework to thinking about all of that. And then I'll show you that all the different ideas you hear about are just special cases for single underlying thought framework. So let's start with, the blueprint of modern recommendation systems. So at an extremely simple level, you have, let's say, a million, a billion, whatever, some crazy gazillion number of things that you could choose from. And you have to show only top 5, top 10 to the end user. At an extremely high level, if you were to do this yourself manually, or someone were to intuit about it, one simple idea is, let's first bring down, let's say, 100, 1,000, 10,000, some number of candidate videos to show, candidate products to show, because out of a billion, almost most of them are not relevant to me as a user. Let's say some of them are, let's say, in Thai language, some of them are in Spanish. I don't speak either of them. They're clearly not relevant to me, right? So if you just filter out to my universe, you can probably bring it down to a small number quickly. And within that universe of things that are relevant for me, you then can do some sorting, some ordering on them, and give me the final results. The first phase is called as retrieval, where you're retrieving items basically. Sometimes it is also called candidate generation because you're generating candidates. And then you're ranking them. Sometimes you might hear the word re-ranking. So if you hear your engineering teams talk about retrieval and re-ranking, this is all they're talking about. There's no rocket science behind that. Now, this is a very simple view. There are a couple more stages in real world systems. Uh, I'll talk about stages 1 to 5. I've added a couple more details and I'll, help you visualize that as we go along. But what is happening is, you retrieve some candidates, you filter some of them out, you then somehow rank them, and you give the final recommendations to the end user. The user then reacts on something. They like some videos or buy some products, which then comes back and becomes, underlying data set using which you can, improve your recommendations further. That's all basically this slide is really saying. So let's go through some of these stages one by one and understand a bit more about that. So the very first stage is what is called as retrieval. Generally, you filter down the inventory to few hundred, maybe 1,000 items, and then do some more heavyweight processing on those. The goal of this phase, however you do it, techniques don't matter. What really matters in the end is you're able to bring all or enough of the good candidates. If you're bringing noise along with it, don't worry about that. That will get filtered out later somehow. So let's say for me, if you are bringing, let's say I'm a huge fan of Eminem. If you're bringing new Eminem videos, whatever else you bring in the retrieval phase almost doesn't matter as long as you bring the golden inventory, the golden content for the specific user. So recall is the name of the game when it comes to retrieval. And if you further dig deeper into retrieval, it is actually very, very simple. People, engineers, we all like to use buzzword, but it's actually very simple. It's a bunch of heuristics. And each heuristic gives us, some number of, items, let's say 10, 20, 50 items. You line up, 10 of them. You take a union of all of that, and these are your 500 items at that point of time. So if, let's say, I were to ask you, You know relatively little about the user at this stage. You don't have machine learning, capabilities. How will you find those thousand things which may contain golden content for me as a user? Well, you might say that, what, let's look at the most popular content on all of the platform and bring, 10 of those. They're probably good. We don't know if they are personalized, but maybe some chance that, there is good golden content here. You might say that let's look at the artist that this person follow in, let's say we are YouTube. I literally follow some pages, bring out the five new pieces of content that arrived from those pages. These are all both valid heuristics. You'll write more heuristics literally at this level of detail only, nothing more complex than that, and take a union of those. um, and then you can begin to add some more complexity here. So you can then say that look at the content I liked in the last 1 week. Then for each content, look up the creator. I've not explicitly followed the creator. All I did was liked some content from those. And then now bring, five pieces of content from each of those creators. So my point is, these are all simple heuristics at the end of the day, and we are using your intuition and understanding of the product to intuit where could gold be for this content. And if this is not accurate, it brings noise, like I said, doesn't matter. What is important is what truly matters should come through from one of these, generators, as they are called. Of course, things are truly not that simple. We end up doing a lot more machine learning within this phase as well. You might have heard of, vector search, embedding nearest neighbor lookups, collaborative filtering. These are all different techniques of filtering out the inventory a little bit, but they have their own problems as well. So if you look at any real world recommendation system, there are a couple of generators that are based on embeddings and math and machine learning. But there are also several generators that are literally based on the ideas as simple as, I've been, giving examples about. So in the end, you take some advanced machine learning, some simple product idea, some trending content, some recent content, things like that. Get 15 items from all of them, put them together, and that becomes your retrieval effectively. Now, once you've done your retrieval, sometimes it brings invalid inventory. Like forget even personalization, literally invalid inventory, which you need to filter out. Maybe let's say in case of e-commerce, maybe there's an item that is now out of order. There's just no point recommending it to any user whatsoever. Or maybe let's say you are let's say you are Netflix, and through this mechanism you ended up retrieving some inventory which there is no licensing in the country of the viewer for that content. There's a bunch of reasons like that. So you'll basically want to filter that out, and that's all the second stage of filtering is about. You define what invalid inventory means to you and try to filter it out. Some products, in fact, this is the norm these days. There is a notion of personalized filtering as well, which is kind of oxymoronic, but it is what it is. And a lot of content feeds in particular try to filter out content you've already seen before. And so they then extend the definition of invalid inventory to say that if I've seen this specific, reel on Instagram before, not eligible for further circulation to this particular user. Either way, the concept is very simple. You got some inventory out through a bunch of heuristics and some advanced machine learning, and then you filter out things that are not relevant to you. The next three stages, feature extraction, scoring, and ranking, are basically expansions of what I was calling as ranking or re-ranking earlier. Retrieval and filtering are expansions of what I was calling as retrieval. So now you have, let's say, 500, contents or 500 products. You have to somehow order them and choose top 10 out of them. How would you do that? Well, the intuitive idea is you want to assign a score to each of them and do some, ordering based on that maybe. So the idea of assigning a score is exactly what storing stage is. And the idea of ordering them is exactly what the ranking stage is. You have to come up with scores somehow, which is where feature extraction comes in. A feature is nothing but a signal about the item, which is useful in the task of recommendation system. So for instance, what is the creator ID of this video? Or what is the zip code where this product sells the most? Or how often has this user interacted with this particular vendor? All of these are signals. You can come up with any signal. There is no right or wrong here. There is no such thing, and this is a good signal and this is a bad signal. Some signals are more useful than the others for the task you have at hand, but these are all valid signals. These are all valid features as well. One thing that you probably want to take away from this is almost always it's been seen, decade over decade by now, and it's somewhat counterintuitive. Behavioral features end up dominating instead of static features. So the natural human way of modeling this is you might say that okay, let's look at the topics this user follows, and let's also look at the topics of this content. And clearly, machine learning model should be able to do match on them somehow. That just does not work. If you look at specified preferences of user, that almost never works. Instead, what you need to be looking at is how are people actually behaving? What are they clicking on? What are they liking? What are they watching? What are they listening? What is the actual behavior of the people on the product instead of any other stated information or preferences? And you want to use that for feature engineering. But either way, we have thousand pieces of content from retrieval. We filter out 100. We are now down to 900. For each of those 900, we start extracting a bunch of signals. There are, let's say, 20 predefined signals. Imagine that. So for each of these 900, we extract those 20 signals for each of them. Once you have extracted those 20 signals, you then need to collapse them down into a single score. But before that, in terms of features, like I said, behavioral features are what matter a lot. So if you look at successful features, this is typically how they look like. You choose some user attribute, some item attribute, some behavioral action, some context, some aggregation mechanism, some rolling window, and a typical feature might be, let's say, for a given let's say content, you'd say let's look at the click rate of users of a certain age demographic on the publisher of the content. That's a typical feature you'll see in a real world recommendation system. And what this feature is supposed to capture is the affinity of a certain age group with this publisher. So, a more direct way for doing this could have been that you ask the publisher to tell you what are the age groups for which the content is valid. But like I said, stated preferences almost never are reliable source, and they just almost never work. Instead, the behavioral substitute for that is you simply look at are people from a given demographic interacting more with that content. If they are, then you have behavioral signal that this page is relevant for people of this demographic. By taking different cuts like this, instead of taking a cut on age, you could have then said instead that how are people of this gender interacting with this content. These are still very broad demographics. You can go more interesting things as well. You could say of the people who follow this particular group, so that limits down people of a certain taste and certain interest. Within those people, what is the click rate with this other content, as an example? And so you are basically finding some user cohort, some content property, taking some click rate, etc. on that. But either way, once you have 900 pieces of content left, 20 features each about all of them, you need to somehow collapse them into a single score. Because how can you even compare 20 different numbers across 900 different things? That process is basically what scoring is called. You could build a simple heuristic. You will that I'll take the average of those 20 numbers. That's a reasonable scoring mechanism. It will probably not be very good in practice. That's a different thing, but it is a valid mechanism. You could say that, I will have only one feature. I would not even have 20. And that feature itself becomes a score. It's also a valid mechanism completely. All of these are valid mechanisms, really. You don't even need to have machine learning model. Of course, machine learning models end up being one of the many ways you can score your content and collapse those 20 numbers into a single number. You could do, just linear regression or, statistical techniques like that that many of you may have experience with. Or you can bring in the big guns and neural networks and, things like that. These are all simply mechanisms to collapse those 20 numbers into a single number. Now, the benefit of machine learning is it can learn many more patterns than you can program yourself manually, and it can learn directly from the underlying data itself. And so there's a bit of it improves itself as new data arrives, and it can capture very, very complex nuanced patterns. But at the end of the day, it is simply a pattern matching thing where you say, oh, if this feature is high and this feature is low, then give a score of 0.3. But if this feature is high and this is low and this is low as well, then instead give a score of 0.1 only. That's basically all that is happening under the hood. But you do some scoring either way. And once you've done some scoring, you basically order things based on that, and that becomes your final ranking. This is what it is in the beginning. Slowly, as you work with an industrial product, it begins to get more complex. Sometimes you'll come in and say, you know what, if I have, 4 pieces of content next to each other, all from, Katy Perry, it's probably not a good idea. We should inject some diversity somewhere. Or you might say that, uh, you know, you know, we have this content that's showing up. It's a real story. At Quora, we had this, good thing where our content had long shelf life. But if you open, Quora and the first 7 pieces of content are all, let's say, 3 years old, it creates an illusion that this is a ghost town. Now, that may still be the most personalized, most relevant content that's probably going to get the most engagement from the user, but it has now a different product dimension on which, let's add some more, perturbation to it of some degree, and, give a penalty if the content is very old, so to speak. Either way, this whole process of going from scores and some other meta information to final ordered list is basically what I'm calling as ranking. Now, I'm not describing stages 6, 7, 8 here. They are a little bit more technical. I think from a product point of view, you need to understand these 5 stages. Obviously, I'm somewhat lying when I say that it's not complex. It's very, very complex. These are just, basic building ideas, but there's a lot of math that goes in behind all of those, and they quickly become very complex. But if you understand this blueprint once, every other idea you might have come across for recommendations is just a special case of that. If you want to say that, let's just order things by, creation time. Literally, the first recommendation system at Quora was, reverse chronological sort of content. You can almost visualize that as there is no retrieval in that system. You have a single feature, which is a creation time of the content, and your scoring is basically just that, and you're ordering on that. There is no diversity, nothing of that sort. If you have some heuristics, you want to say that, let's look at the number of likes, divide that by number of impressions, and that ratio is how I will rank content. Valid heuristic. You have no retrieval. There may be 2 or 3 features, maybe like count, impression count, and so on. And your scoring is now a manual weighted average or ratios or things like that. If you have, let's say, let's just sort it on popularity, you now have a single retrieval generator, which is most popular content, and you don't have any features, any sorting, any scoring, nothing on top of that. You literally just have a generator, and whatever output that creates, those 100 things, you take the most 20 popular content, and that becomes your final recommendations. Collaborative filtering, content-based filtering, neural nets, two-tower networks, combination of all of these, they're all basically special cases of this blueprint. So as a product manager, I think what is the most valuable place for you all to create value is understanding this blueprint and asking yourself, does my product need work on the retrieval? Do I need to be filtering out more invalid inventory that I'm not filtering out? What signals should my team be thinking about? How do I go about it, collapsing them down a score? And you can share your product constraints with the engineering team, and they can usually convert them into math quite well. But if you start telling them about two-tower neural network, like, you don't know what you're talking about, and it's probably not going to work anyway. So anyway, so all of that is good, but I think another thing that's happening, and probably happening in all of your companies, is machine learning is going real time everywhere, which is also somewhat counterintuitive, because the general impression isn't that only for TikToks and Facebooks of the world and Googles of the world. We just need to get something going, 80/20 and all of that jazz. I should just get something out, it'll probably be good. I don't need to do fancy stuff. That's actually not the case. So let's look at why that's actually not the case here. It is really, really bad for product experience for your recommendation systems. And more generally, machine learning systems should not be real time. Imagine a couple of scenarios. Let's say I just signed up. You have a batch pipeline that computes recommendations every midnight. I signed up, let's say, 7 a.m. For the next 17 hours, there are no recommendations for me, or you're at least not utilizing the information I'm giving you to give me something personalized. Maybe you have most popular content and you show me 10 of those or something, but they're not a good experience. And I think we all know that the retention drops most rapidly in the first couple of sessions itself. Similarly, imagine you are on the other side of the marketplace. There is content, a producer, a vendor, whatever. They come in, they upload some content, and for the first 24 hours, they don't get any distribution for their content. they're probably not coming back. Their attention also drops. Um, and there are many, many more reasons. I've written a whole post on it. There are 7 different reasons I've identified, at least 7. There are actually many more why you need these systems to be real time. But if you care about cold start, and if you care about long tail, which you almost certainly do in modern economies, like modern digital products, you probably need to be somewhat real time. And one thing is theorizing about these things. The other thing is, what has been seen time and time again. So, science works, machine learning works, and similarly, real-time machine learning ends up producing significantly better products as measured by their top line engagement and top line revenue and those kinds of things. So when you are leading your team to set up machine learning, don't brush it off as a like a first world problem. Let's first build the 80/20 solution. It's actually a pretty fundamental part of how these things are built these days. The next question that comes up is, aren't these things too costly? Well, um, imagine a counter example where you are going to pre-compute things every midnight. You don't know what users are going to log into your platform the next morning. And so what you'll do defensively is you'll say, let's pre-compute it for literally damn everyone. And probably, unless you are Facebook, only 5% of your users are going to come a given day, probably less than that. And so all of that 95% of the computation and storage you did is now wasted. When you go to real-time world, the per unit cost of computation is higher, but you end up doing much less amount of computation because it's done incrementally and it's done on demand instead of pre-computing a gazillion things every hour, every day, and then throwing almost all of it away. So it is important for product experience. And from an infrastructure cost point of view, it actually ends up saving you money as well. And then, the last question sometimes people have, isn't it too hard to build? Isn't this, too much of a heavy lift? And we don't have, headcount for that. Well, these systems historically have been harder to build, but good tools are coming in which make it easier. And I think what people also don't understand and recognize is in many, many, many ways, these are actually simpler to build and operate compared to batch systems. So imagine there's a batch system that is running. It last ran, 21 hours ago, and there's a very complex jungle of pipelines that feed into each other. And from that comes recommendations. And your CEO goes to the product, they're like, this is a horrible recommendation. Why am I seeing this? Good luck backtracking from there and debugging and then trying to improve that. If you're trying to, do A/B testing, which you should be doing all the time, how many versions are you going to pre-compute for the whole population? It's going to get really costly, really, really quickly. The pace at which you can run A/B test ends up getting limited by the frequency with which you can compute these batch pipelines. There are many, 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 many reasons why in practice these actually turn out to be a lot harder to build and operate compared to a well-built real-time system with the right thing. So I think the second takeaway, in addition to the 5 stages and where you should be putting your leverage, is if you see your teams telling you that, or maybe your executives, or maybe you yourself telling you more likely than not, that let's, think about all of these stuff later, try to resist that temptation, at least investigate a bit further, and you'll usually find that it's, high enough ROI. Okay, since I have the platform, I also want to, use a few minutes to talk about, what Fennel does. And obviously, I'm trying to build up, awareness of what my company does, but through this, you'll also understand some other important aspects of, real world concerns that actually matter. So, we are what is called as a real-time ML feature store. When you are doing feature engineering, you need some mechanism, some infrastructure to compute all of those signals and keep them fresh as new information arrives, and do low latency serving of them, but also, training data generation. A lot of complexity, drift detection, monitoring, governance, all of those things. I worked at Facebook for a while. My founding team worked at Facebook as well. Ex-CTO of Facebook, current CFO of Facebook, head of AI platform at Facebook. They're all investors, advisors in our company, along with, creator of Kafka and, a co-founder of a bunch of companies and, VPs in more companies than I can count. It's based on ideas built at Facebook through, I'm going to say, maybe 8 years of hit and trial, not by me or my teams only, but through, 1,000 different machine learning engineers. So standing on the shoulder of giants here. Um, Facebook is obviously several years ahead of the rest of the world. So we have the luxury of, doing hit and trial and figuring out, how to build and operate these systems. But at the same time, it is adapted to the needs of the rest of the world. Most of you do not have 100 gazillion, size inventory and like a several bazillion people using you every day. But, the same idea has been adapted to your scale and your needs. Um, Now, these are the problems that we set out to solve, and these are the problems your teams are experiencing. And if you already work on machine learning, you probably hear about some of them on a daily, weekly basis, and some of them come to you from higher executives as well. As I said, if you're trying to make your systems more real time, which I think you should, there's no reason not to in 2023. You want your features to stay fresh and update with new arriving data, the signals that I talked about. That's what is the click-through rate of this user on this demographic, whatever. As new clicks are happening, as new impressions are happening, you want that to change. And you also have to do low latency serving when the user does come to your website. You quickly have to find out those 20 signals for those 900 candidates. That's 18,000 data lookups. In practice, it is actually a lot more than that. And so, latency starts mattering a lot. On the authoring side, your machine learning teams and machine learning teams worldwide write Python and they are productive in Python. The whole ecosystem is in Python. In fact, at PyTorch, our whole strategy was let's build up a very strong PyTorch ecosystem. That is exactly my role at PyTorch was as well. And almost certainly the rest of your tech stack is not in Python or not in data science friendly technologies. And if you force your machine learning teams to write Java, good luck. You're not doing any innovation there, I can assure you that. And so, you need some mechanism that they can continue doing Python, but then, play nice with the rest of the tech stack you have. You obviously want good unit testing, CI/CD, all of those things to maintain software health. And that is really important because software health translates into quality of features as well. Far too often, what happens is your features are not what you think they are doing. They get corrupted, pipelines break, they become, null values all over the place. And a year worth of forward progress in machine learning has been undone because of that single bug. And you don't find out about that bug for like 6 months until your CEO is literally shouting when you're telling you that, hey, you need to figure out why our ML models are not working in production anymore. Every ML system drifts, people's behavior shift. And the models you trained 3 months ago, they are not effective today. And this is not a theoretical concept. Like every single time, in every single context I have been, if you take a model and you plot its effectiveness over time, it's high in the beginning, but then falls very rapidly. And a few months in, it's basically not, more than maybe, 60, 70% of effectiveness it had when you started with it. And so drift is a real thing, and you want to understand that. More likely than not, if machine learning starts working, you will have many, many use cases of machine learning very soon. You may have a couple of headliner use cases like a recommendation, but you'll be doing machine learning everywhere. And you'd want to reuse the machinery you built up, reuse features you built up. In some compliance industries, you need to know lineage, how what the data feature depends on as well. And finally, there's a lot of operational burden of just running these things and building them and managing the reliability and managing the cloud cost and bringing it all down. These are all the problems that we are trying to solve at Fennel. Your machine learning team still write the features, they still train the model there, and you as PMs are still in charge of the product direction and product personality, so to speak. We are just giving you a piece of infrastructure to make all of that easier. We are not giving you intelligence. A bad, metaphor I make sometimes is we are not giving you brain, we are giving you the skull that will hold the brain, so to speak. So you still do all the intelligence. It runs inside your cloud in a way that data and code never leave. So if you are in a privacy, security sensitive, you get all of that as well. And the effect of this is you get more powerful machine learning capabilities, more real-time capabilities, your models are better, your products are better, your business value is higher, your metrics are higher, your iteration cycles have become shorter, and so time to market is a lot higher, both launching a new machine learning system and product for the first time and then ongoing iterations on it forever. And all the dimensions of cost from cloud to people cost are coming down. We are easy to use. We have a lot of focus on quality. We operate on the whole spectrum of batch and real time in a very powerful way. I will not bore you with the details here. And that's basically all about Fennel. We, as Mahesh said, we write a lot about recommendation systems and more generally machine learning on our blog with the level of detail and clarity that I showed here. And so if you want, go to Fennel.ai/blog, good educational content. If you want to read about what Fennel does, you instead go to Fennel.ai/docs. And if at some point of time you or your company is interested in evaluating Fennel commercially for your use cases, or just learning more in a casual way, not even any commitment, you can reach out to me. I have my email here, Nikhil@Fennel.ai, and then you can take it from there. I think that's all I have. I want to stop here. I think we still have some time for questions, so I'm going to take some of those now.
Thanks, Nikhil. People from our cohort, feel free to ask questions. Nikhil has been a great source of knowledge and learning for me when I was at PyTorch. So please use this time. Go ahead if you have any questions. Others, please write your questions. I might be able to take one or two. Just raise your hands and go.
I think there's a question in the chat.
Yeah, Mozin, you want to ask the question? Go ahead.
So I have some noises, so if you can hear me, I can ask it.
Yeah, we can hear you.
Can you hear me? Okay. Okay, so my question is where the most transition is happening now from batch to like real time machine learning, maybe especially industrial, or I can phrase it as like, what is your ICP, ideal customer profile for your company?
Yes, I think the answer to the first question is literally it's happening everywhere. And that's probably not the answer you're looking for. So let me now give you a slightly different answer. If you zoom out, there are two kinds of machine learning problems in the world. One set of problems that operate on language words and video frames and image pixels and so on. And your chat GPTs are a new addition, new incarnation of that. Those are often by definition static, like your video content is not going to change very much. There's a different subset of problems which are based on domain specific, structured behavioral data, like fraud detection, like insurance underwriting, like recommendations, like dynamic pricing, like inventory forecasting and optimization. All of those areas are going real time very rapidly. There are some where it is, it's just a business imperative. Like for instance, if you're trying to do fraud detection of any kind, you absolutely have to do it real time. There is no point blocking a transaction 24 hours after the credit card swipe went through. You have to do it in the moment, and you have to use the information that happened recently. If you're an insurance underwriting company or a credit card lending company, someone applies for the application, you can take them 3 seconds to get back to them, but you cannot take 6 hours. And so there are many verticals where this is just a part of business imperative. But even when it is not, like recommendation system, it's very rapidly going towards that direction. The next question, I think, let me just read them out in spirit of time. From RJ is, how would explainability work with real time? Explaining why an ad product was recommended. I think I'll flip that question around and I'll ask you, how will it work in the batch side? And whatever you can do in batch, you can do that in real time, but in real time, you can do a lot more. So for instance, usually the way it is done is, as recommendations are created, like I told you that there's more complexity than I'm giving you the hint for. As recommendations are getting created, people typically tag each recommendation with some metadata about it and pass it along the funnel. And so that metadata typically has information about what retrieval generator created that. So if I can show you that we are showing you this because it is trending, or we can showing you this because you are following this page, or something of that sort, that's basically good enough for explainability point of view. You don't need to go in the nuts and bolts of how it happened. You can do that in batch and you can do that in real time. But in real time, you can do a lot more. What you can also do, for instance, is trace a full path of a given piece of item along the full funnel on demand when you want to. Whereas in batch pipeline, that is a lot harder to do. Does that answer your question, Ajay?
Yes, that does. Thank you so much.
I can go with the next question, Nikhil. When people are starting on real time, like we learned, if you want to go with rule-based or simple mathematical systems, you need less data, then you go to deep learning, then you go to further large models. the amount of data that you need to bring or build recommendation system goes to 10x every time at least. What's the bare minimum funnel needs for people to get started?
I think,
What kind of data you expect them to have?
yes, I think in my experience, you know, the number of companies that need large models for recommendations is probably in single digits as of right now. And the number of companies that need deep learning for recommendation is in a single digit percent. And so for almost all of us, what we really need to be using is more conventional, simpler machine learning. There's a particular technique called as gradient boosted decision trees, or GBDTs,
Yeah.
as they are called. 98% of us will just be using that for all of our careers. They work so well and they are so simple relative to neural nets, and the kind of data that most people have, that is needed for neural nets, most people don't have that kind of data. For Fennel in particular, there is no scale limit. Even if you're trying to do simple rule-based heuristics, you still need features for that. And a lot of the problems that I mentioned here, some of them are scale related, these problems, but many of them are not. And so Fennel can still create value. Obviously, beyond a certain point, it begins to, make a lot more sense. But for Fennel in particular, there is no limit. And outside of Fennel in general, I think, you should probably assume that you do not need deep learning for your structured data problem. You need them for, vision and language and those kinds of things, but not for structured data problems.
Neeraj, you want to ask your question? Go ahead.
Yeah, you spoke about this two tower model, and we have user features and product features. But I'm trying to understand, how do we deal with negative samples? Like if we just learn what the user clicked, then it could lead to overfitting, right?
Yeah, so I think so this is a pretty advanced question, but I think the answer to your question is negative. So let me first help all of you understand, I think, what the question is trying to ask. If let's say I am training my models only on the things that user clicked, model could learn to parrot that user is interested in everything, and they'll still be correct on the training data on which I'm training my system, which is clearly not the behavior we want, with them to have a very fine sense of discriminatory power, so to speak. And so for that, you need to do negative sampling. There are many techniques of doing negative sampling. You could do just literally random negative sampling. You could literally choose, random 1,000 pieces of content and just pretend that user saw them and did not like them, and just say, hey, these are, bad pieces of content for this user, and that works reasonably well. And from there are many more, complex techniques of doing negative sampling. But once you have chosen some, negative examples, you still need to come up with the same features for that. You still need to, do the scoring for them, and then teach your ML models to be behaving in a way that the score for them turns out to be low. Answer your question, Yash?
Yeah. Yes. Thanks.
Last question for today.
I'm seeing two questions here. I don't know if my video froze. One is from Philancy. How do you deal with governance in your product? We deal with governance beautifully. I think that's a short answer. There are a lot of nuances, when it comes to dealing with governance. We have automatic lineage understanding. We do lots of different kinds of monitoring. We, first of all, try to have things built in a way that your system does not even get into bad states of data quality to begin with. But if it does, we have lots of different kinds of monitoring and alerting on it. We also have role-based access at those kinds of fancy things that you need to ensure compliance and governance. So, Lance, if you are interested, hit me up and we can have a conversation on that offline. And I guess in spirit of time, the last question is from Anushil. How difficult is it to change a legacy recommendation system if the goal changes from acquisition to retention or revenue? So I think I probably want to mention one thing which I think is quite important. The highest leverage point in a recommendation system is not the algorithms or the features or even the data. I think the highest leverage point is the measurement. And so if you as product manager are able to come up with what is the success criteria of the recommendation system in a way that it can be written almost like a math, like it's very precise, that this is the metric that we care about optimizing. Reworking the machinery to optimize for that is some effort, but relatively speaking, a small amount of effort. compared to building the whole thing from the first place. What will most likely happen is you'll still do retrieval, and more or less almost the same generators will work. You'll still have invalid inventory that you'll filter out probably the same way. You'll still extract exactly the same features more or less because they have predictive power of user behavior. Only the scoring phase is one that will probably change. Instead of taking, let's say, weighted average of ABC, maybe now you take different weights. If you were to do heuristic as an example, if you're training your ML model, obviously you tell ML model that this is a metric I care about, and ML model internally comes up with the right pattern or right formula internally to do that for you. So the answer to this is you focus on the measurement side, that then gets converted into the scoring stage, and the whole recommendation system has now adapted in personality from there.